So this is Todd, and Catherine's behind the camera here, and we're here to tell you today about our Starlink setup, which is over here. But first, I do want to mention, to make sure you pay attention to the whole video, is we do have a question for you. It's related to sailing, and we're wondering about when the geese fly south through the winter. You know how there's like one line of the V is longer than the other? If anybody can answer that question, we will answer it at the end of the video. So anyway, getting to the point here, we just got our Starlink, and I want to walk you through real quick the two components of the Starlink system. First, we have what they refer to as the dishy. Now, you can see it's kind of flat, as opposed to old satellite dishes that were curved like a dish. And the reason why, and I want to stress here, I'm mentioning all this stuff because it's important for you to understand, so when you do your setup, you know the motivations and what you need to consider in how you do it. This satellite dish is set up with a phased array, it's called, and it has all these little different sensors inside behind this white panel that pick up the satellite signal. What it means is that before, satellite dishes had to point directly at the satellite to pick the signal up. This does not have to do that anymore because the individual sensors will point, and I'm told they can pull a satellite within 50 degrees. So it's not as critical for the dish to move around. Now, it does move around at this pivot here to orient itself and pick up the satellite signal initially. So anyway, so that's the dish. And then the other component is this router, which is also a power supply. So there is this plug. The plug plugs into here, and then an outlet. Now, we're in Europe, so this is a European plug, but in America it would be a standard 120 plug. So that provides power to the router, which then this cable attaches into here and into the router base and goes to the dish. So this router serves two purposes. It provides the router to provide the Wi-Fi network for your boat, and then number two, it provides power to the dish. Now,
are you going to show us where on the router and where on the dish they plug in?
Yeah, so the router has underneath here, there's the plug for the electric, where you plug into the electric, and that's the plug to plug into the dish. So it's this long cable that they have, longer than you're going to need, but better longer than too short.
And what about on the dish?
It plugs in quite easily. It slides right into here like this. And that's plugged in and then unplugged. So it's pretty weatherproof too. So that's a nice feature. So it's easy on, easy off. Now, our boat overall, we have what a lot of people like to have is a lot of solar, which you can see here, and also on our coach roof and our salon roof. We have 2,500 watts of solar. So our boat, for the most part, runs off solar power, which is direct current. So the solar is direct current, it goes to the battery, charges the battery, and then the boat pulls the power from there. The reason why you need to be aware of this is that the Starlink system runs off AC power, the standard power that you get in your house. So, but it is more efficient to run off DC. So going into our configuration motivations, one, we want to run off DC power. And there's the main reason for that is that when your power comes in, your solar panels charge your batteries. That's all DC. Now, if you need to plug it into an outlet, you need to turn your inverter on, which is AC, alternating current. And then this router turns it back into DC current. So it's just, you waste energy every time you make that conversion. And the other issue is you have to have your inverter on in order to run the Starlink. So if you're planning on running it all day, you have to have your inverter on, and the inverter does use some energy just having it on. So that's the DC power motivation. Number two issue is the existing router. We already have a PEP wave router on our boat, so we don't want to have a separate second router you want to
Pep wave runs under our nav station.
Yeah,
in there.
you want to look at, we'll
No.
show you that in a minute. So we'd like to tie into that. And then the third motivation is on-off ease, turning the system on and off. We have the boat, when we bought the boat, the Wi-Fi network, which has the PEP wave on it, is tied into a switch that we can turn off and on. So if we tie it into that circuit, when we turn the Wi-Fi on, it will also turn our Starlink dish on. In terms of how we're planning on running this, my plan is to come back here. We have a fishing rod holder right here. So I'm gonna get a pole, I haven't gotten it yet, that extends up here, and we'll mount the dish so it has a pretty good clear sky view here. And the other consideration is that we can remove it very easily here and store it away. If a storm's coming in or we're doing a big passage, we don't want it out, we can just pull it out. The plan is to run the wires through this cabinet here into here, and just come out. The wire would come out through this notch, and we'll show you when it's done, and up through the hole for the Starlink dish. The other reason I want to do it works well for here is that from inside this cabinet, I can run the wire under into the engine room and through the hole all the way down the hole to the nav station, which Catherine had shown before. So it's relatively easy to get the line run. And looking under the nav station, there are two things I've already done. One is, if you look at the arrow below, it shows the 12, 24, 48 volt PoE injector. I've already wired that up. Now, what a PoE injector is, and as I mentioned before, the router is a power source that converts AC power to 48 volt DC power for the Starlink dish. That's what you need, and 48 volt DC is the standard for Starlink, or for all telephone and internet cables for power. The other thing that you might have seen under there, and maybe Catherine can take a look again, is our PepLink router, which has already had been installed by the original manufacturer. So I've already attached the power to the PoE router. I just have to extend the phone lines over to the Cat6 lines over to the PEP wave, and then also attach the satellite dish. There are a few modifications we have to do with that, and we'll show you that on the second half of this video, where I show the final installation. It's been a couple months or so since I started this video, and we finally gotten the Starlink all up and running, so I'm following up with other details on the setup. One thing I did want to mention is that we do have this Wi-Fi puck, which is really handy. You put a SIM card in it and you can take it with you. It's got a little battery in it. We mostly leave it in the boat, but it gives, it's been very good with providing Wi-Fi. It basically works off the cell phone network. You just have to get a SIM card in whatever country you're in. But if you have a car, or you're going on a bike ride or whatever, you can bring it with you and you still have Wi-Fi. So we haven't had a real urgency, because we're traveling around Europe, to really get the Starlink all up and running. But redundancy is good, and that's our motivation for getting this Starlink set up. Just to review really quick, the principles of what we are trying to do with the Starlink is, number one, convert from AC power, which is how the Starlink is set up and configured, to DC. So we don't have to have our inverter on all the time when we're running Starlink. Number two, we do need 200 watts of power to run the Starlink. That's really the max power it needs when the dish is moving around. For the most part, it's only using about 50 or so watts, so not so much. And then two, we do want to run our existing PepLink router instead of the Starlink router, so we're reconfiguring it so we can do that. and I'll be talking about this a little bit. The wiring of the Starlink is basically Ethernet wiring with 8 little wires, but they change the sequence of the wires, so that's one thing you need to be aware of, and we'll talk about that in a little bit. So since the last section of the video, I had this pole made up, which has a little notch in the bottom and a place for the Starlink to fit to. And I do have over here, I'm going to set this down real quick. I ran my cable, and my Starlink cable, which is about 150 feet long. I obviously didn't need quite that much, so I cut it a little shorter. But here it is, and it worked out just fine running it through that cabinet, and it comes out this little notch right there. I basically have it running under the hull here into the engine compartment along the whole hull to the nav station. Now, we'll go see that in a second. But for now, I take my cable and I slide it. This is the original cable that it came with the fitting, and slide it into the dishy like that. And then I have my pole, and I slide this into here. I had this pole made up by a metal guy. He put a bolt here so we can clamp it down so it doesn't move around. Also I have, what did I do? 1 second. So that's that. And then also I put a little notch at the bottom here. You can see, because I have it attached into the fishing rod holder here. So when I set it in with the Starlink in the top, slide it down and spin it, it clicks in, and that way the Starlink is all set and it won't move, it's not going to move around much. Now, as I said before, and I'm not sure I need it quite this high, as I said before, when we're in rough seas, we're not going to have it out here, but only when we really need it. And I would actually advocate for doing what other people have done, is take the motor out, mount it flat somewhere. Our challenge is we really don't have any good place on this boat to put it because we have so much solar. So for now, I'm doing that. So as mentioned, the wire runs under the hull here, through the hull, under here, and then up into the nav station under here. Now, in the nav station, you can see the wire coming in right here. That's the Starlink wire. And I have it run, I have my PoE, which is power over internet. The Starlink comes into there, and then it comes out. That's the Ethernet cable that comes out and goes up to the PEP wave. Can you see that? And then let me move this over a little further. That's my Orion Victron Energy 24 to 48 volt power converter. And that power comes in right with the white wire over there at the top here, right here. So that brings 40, converts my 24 volt to 48 coming into the PoE. So one thing to keep in mind, here's the diagram of it. So you saw the 28 to 48 volt converter. As mentioned before, most phone lines, internet, whatever, they run off 48 volt power. So the power goes into this Tycon PoE injector. It's 1,000 watts. Make sure you get that injector. I had another one that was shown in the last video. It didn't work. It had 95 watts, which I thought, well, maybe that's enough. It's not. The Starlink wouldn't move around and what have you. And then I showed you also the PEP wave router, so that's connected there. So this PoE injector basically takes the voltage coming in from the converter, and it sends it out to the dishy, and then dishy sends back the data to the PoE on the same cable, and then that sends out to the router, which then runs my Wi-Fi network on the boat. So And let me show you over here. I'm not going to get in total detail into exactly how to do this wiring. There's several other sites that show you this. A guy named Everlander and Outside Nomad. And basically, here's an Ethernet cable. Excuse me. You want to make sure you get the shielded kind, which means it has metal over the plate here. And you see this little foil here. And it's got a wire there, extra wire.
Show that other thing too.
So that has the metal covering. I'm not sure exactly what it does, but it does something, keeps the interference down. So what happens is you have to get these little connectors, and
Show me the connector.
There are 8 wires that go into there, and they thread through this connector, and you can see the 8 little metal pieces there, and you got to get them in the right order. It's a little fussy and tricky to get them in, but it works. Basically, you get the wires in here, you have your crimper tool, and you put your crimper with the connector running into here. You crimp it down, and then it locks all the wires in place, and you're done. You got a crimp wire. You can put a cover on top of it too, and that you can buy. Basically, the little piece that goes from here to here that makes it a little cleaner. Incidentally, that's my old PoE injector. Wanted to mention one other thing is that the swapped color codes are here, but as noted, you should really go to either Outside Nomad or Everlanders. They give more detail on where the wires go, and you can see there's like gold dash, blue, green dash, green, blah, blah, blah. That's these colors you see here, and this is the order they need to go into that fitting. So on our boat, we have it's called a C-zone control system for all our electric. There are other similar systems like this, or some people just have a hardwired system. A lot of people do with switches. So anyway, on ours, what we do is we go into our C-zone and we hit control on it, and then I can scroll down to Wi-Fi router there, and I actually already have it on, and you can see it's drawing 1.9 amps. That's
1.5
or 1.5 now, so that's at 24 volts, so that's under 50 watts of power. It's been on, it's running fine, it's all set up. Oh, the other thing to make sure you do is that what I did is I ran the dish and all that electrical setup that I talked about through the Wi-Fi circuit that was already hooked up to the boat, which was hooked into that PepWave router. So, but because I'm drawing more current now, I had to up the amperage to 10 on the fuse. Before, I think it was a 3 amp fuse, and I would have blown that. Also, just on this system, you have to go into the C-zone and tell it now is a 10 amp fuse, because if it draws more, you get an overcurrent message. So most of you won't have to deal with that. The other step you have to do, if you have a PepWave router, and I'm not sure on other routers, but our PepWave router, is you have to go into this website. What you need to do is first select your Wi-Fi.
What website is this?
Well, before you do that, you go Wi-Fi, and then our Wi-Fi for the PepWave is HH50N4. That's our boat's HH50 catamaran. So that you go on that Wi-Fi setting, and then you go on a website. It's a weird one. You type this address in, 192.168.100. I think you can do 50 also at the end here. Anyway, it'll pull up this PepWave, and I can do it. Well, I'm not going to do it again. Anyway, it comes up, and you have to enter a username and password, which is admin, and then then it'll go in. Now, I already renamed the WAN
Where's admin?
It's
That doesn't
before I already logged in. So just know you have to, that's how you log in. I renamed this WAN network. It used to be called Bad Boy, which was the antenna we had up on the mast. So when you plug your PoE out, Ethernet cable that comes out into the into the PEP wave, it should go in the WAN slot. And now you can see here, as I said, it used to be called Bad Boy. I renamed it Starlink. It's all connected here. We're all good. And we can also run a speed test on it. We have this other phone here. And I'll just hit go, and you see it's hit set up SpaceX Starlink go. Now we're in Venice right now, so I know how this works. I think you'll get higher speeds in other locations that aren't so populated, because I've heard basically the RV version, it gets lower priority than people with a fixed version of Starlink. But you can see there we're 94 megapixels download, and it's not as fast on the upload. We got 14 before. It looks like we might be a little less now. So yeah, 12.6. So there you go. A couple other things. I did want to thank our graphics department for their excellent work on all the graphics here. And finishing up too.
The graphics department is me, and she had nothing to do with these.
The color codes are genius, though, huh? One other thing, and this kind of a workaround. This came up after we did this. I did this whole setup, but you can get this, and Everlander references it. Dishy Dooley DC power supply. You can look at this website, boondocker.io. It's a Canadian company, and I think it only cost, well, it's 130 Canadian, which is about 100 US, so it's cheap, but it does a lot of what we did here. Now, I can't attest to how good this is. I assume it all works and everything, and probably if I was doing it over, I would have bought this, and just, it combines a lot of the things that you need. So you might want to get this instead and look at how that setup was done. And then, what's the last issue? The geese. Oh, the geese, yeah. So the geese are flying south for the winter, right?
Is this, you're referencing your very, very first video? Is this what you're doing?
Well, the beginning, of the video. And one end of the V is longer than the other usually, right? And this is good for sailors because they understand winds and all that, and aerodynamics.
She is bored. She's heard this joke before.
So, Catherine, do you know why one end of the
Yes,
V is
I
longer
do know
than the
why.
other?
Yes, but maybe you should tell us.
It's because there are more geese on one side of the V than the other.
That's right.